Hello. The title of today's lesson is Solving Quadratic Equations, and the objective of this lesson is to be able to find the roots of a quadratic equation algebraically, as well as be able to explain how some quadratic equations have two, one, or no real roots, and finally be able to find how many, if any, a given quadratic equation might have. Quadratic functions are in the form of f of x equals ax squared plus bx plus c. But of course, it could also be y equals or t equals or any other variable. When graphed, quadratic functions are represented by a shape known as a parabola, with properties such as max, min, vertices, and roots. The vertex of a parabola is the highest or lowest part of the graph. The roots of the quadratic function, also called zeros or x-intercepts, are found where the graph of the parabola crosses the x-axis. The vertex can be located at the origin, below the x-axis, or above the x-axis. A quadratic function may have 2, 1, or 0 roots. Let's try identifying some roots graphically before learning algebraically how to do so. Here we have the graph of x squared plus 6x plus 8. How many roots does the graph of the given parabola have? 2, 1, or 0 roots? Remember, graphically we see the roots by where the graph crosses the x-axis. We need to look for where the graph crosses the x-axis. We can see that it crosses here at -4 and then again at -2. Since the graph crosses at these 2 points, these are the roots of the graph. So the roots of this graph are as x equals -4 and x equals -2. Let's look at another graph. Here we have the graph for the quadratic function 3x squared minus 27. How many roots does the graph of the given parabola have? 2, 1, or 0? We need to look for where the graph crosses the x-axis. We can see that the parabola crosses here at x equals -3 and then again at x equals +3. The graph crosses the x-axis at 2 points, so that means that there are 2 roots for this quadratic function. Okay, now we have the graph for the quadratic function x squared plus 4x plus 12. How many roots does the graph of the given parabola have? 2, 1, or 0? We must find where the graph crosses the x-axis. Let's look at this graph. Does any part of this parabola touch the x-axis? No, it actually does not. So there are 0 roots for this quadratic function. There are no x-intercepts and therefore no real roots for this quadratic function. The answer is 0 roots. Okay, assessment time. Now let's see how well you understand identifying roots from a graph before we move on to finding roots algebraically. For our first quadratic function, we have 2x squared plus 3x minus 9. How many roots does the graph of the above parabola have? A, 2, B, 1, or C, 0? Take your time and think about it. Now looking at the same graph, what are the roots of the parabola above? A, x equals -2 and x equals 1.5. B, x equals -3 and x equals 1.5. Or C, x equals -10 and x equals 2. Take your time and think about it. Next question. We have the quadratic function x squared plus 4x plus 5. How many roots does the graph of the above parabola have? A, 2, B, 1, or C, 0? Take your time and think about it. Now looking at the same graph, what are the roots of the parabola above? A, x equals 0, B, no real solution, or C, x equals 5? Take your time and think about it. Finally, we have the quadratic function x squared plus x minus 6. How many roots does the graph of the above parabola have? A, 2, B, 1, or C, 0? Take your time and think about it. Now looking at the same graph, what are the roots of the parabola above? A, x equals 6, B, no real solution, or C, x equals -3 and x equals 2? Take your time and think about it. Great work. Now we know how to find the root of a quadratic function when graphed. We can now focus on finding the roots algebraically when there is no graph provided. We will use what is called the quadratic formula in the form of x equals -b plus or minus the square root of b squared minus 4ac all over 2a. This formula helps you find the roots of a quadratic equation using the coefficients a, b, and c from the standard form of the quadratic function. So let's start with only labeling the coefficients a, b, and c. Let's look at this quadratic function. X squared plus 4x minus 21 equals 0. Remember, we set quadratic equations to 0 in order to be able to use the quadratic formula. A is the coefficient in front of x squared, so a equals 1. Remember, when we don't see a number in front of a variable, it is understood to be 1. B is the coefficient in front of x, so b equals 4. And c is the constant, or term without x, next to it, so c equals -21. Leave some space. We'll come back to complete this function problem. Now let's look at another quadratic function problem. 2x squared minus x plus 4 equals 0. Label A, B, and C. Take a few seconds and think about it. For A, you should have had 2. B, you should have had -1. And for C, you should have had 4. Go ahead and correct that if you've had any problems. So for number 3, we have x squared minus 5x plus 10 equals 0. Label the a, the b, and the c in the function. Make sure you leave space for the next problem. And for number 4, we have negative 2x squared plus 2x plus 9 equals 0. Label the a, the b, and the c. Take your time. Now for step 2, we will substitute the values for a, b, and c into the quadratic formula to find the roots of the quadratic function. Remember the quadratic formula? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, a number next to a variable or a variable next to a variable means we are multiplying. So 4ac is 4 times a times c, and 2a is 2 times a. So we use the values for a, b, and c to plug into the formula and solve for x. Let's go back to number 1. X squared plus 4x minus 21 equals 0. We've already identified that a equals 1, b equals 4, and c equals negative 21. So now let's plug these values into the quadratic formula. You should have x equals negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 21 all over 2 times 1. Go ahead and check your work. Great. Let's do the same for the other quadratic functions. We already know a, b, and c. So now let's look at number 2. 2x squared minus x plus 4 equals 0. We know that a equals 2, b equals negative 1, and c equals 4. So plug these values into the quadratic formula. Take your time. You should have gotten x equals negative times negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 4 all over 2 times 2. Okay, let's take a look at number 3 and number 4. For number 3, we have x squared minus 5x plus 10 equals 0. You should have completed finding and labeling the coefficients a, b, and c. Let's see how you did. A equals negative 1, b equals negative 5, and c equals 10. Okay, so now take this time to substitute the values into the quadratic formula. Take a few seconds and pause if you need to. Good. You should have x equals negative times negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 10 all over 2 times 1. Go ahead and check your work. Now let's look at number 4. Negative 2x squared plus 2x plus 9 equals 0. Let's see if you answered correctly when you labeled your coefficients. A should equal negative 2, b equals 2, and c equals 9. Great. Now let's substitute our values into the quadratic formula. Take this time to try on your own. You should have gotten x equals negative 2 plus or minus the square root of 2 squared minus 4 times negative 2 times 9 all over 2 times negative 2. Correct any mistakes you might have made. Okay, great. Now that we know how to identify a, b, and c, and we can substitute these values into the quadratic formula, let's solve so that we can find the roots. Remember I said to leave some space for solving. Let's go back to number 1. Let's solve the quadratic formula for number 1. We will start with the 4 squared and multiply this 4 times 1 times negative 21. And on the bottom, we'll do 2 times 1. Now we have x equals negative 4 plus or minus the square root of 16 minus negative 84 all over 2. Next, we will simplify everything under the radical. Remember, negative and a positive will affect how our answer and how many roots we have. So as we look under the radical sign, we had 16 minus negative 84. Remember, when we subtract the negative, it's the same thing as addition. So it's 16 plus 84, which equals 100. So now we have x equals negative 4 plus or minus the square root of 100 all over 2. We will take the square root, which will give us 10. And now we should have negative 4 plus or minus 10 all over 2. To show respect for the plus and minus sign, we will write the problem 2 times. So you should now have x equals negative 4 plus 10 all over 2, and negative 4 minus 10 all over 2. Remember, we do this because the plus and minus tells us we have to do 2 different operations. Now we will simplify. Negative 4 plus 10 equals 6. 6 over 2 equals 3. And negative 4 minus 10 equals negative 14 over 2. Divide, and we get negative 7. X equals negative 7. So these are our roots. X equals 3 and x equals negative 7. These are the points where this function crosses the x-axis. Now let's do the roots for numbers 2, 3, and 4. For number 2, we had 2x squared minus x plus 4 equals 0. We set up our quadratic formula for it already. And when we simplify it down under the radical, you should have 1 plus or minus the square root of 1 minus 32 all over 4. When we simplify under the radical, we get 1 minus 32, which equals negative 31. And here we should stop and pay attention. Whenever we have a negative number under the radical in the quadratic formula, we can automatically know that the function will not have any roots, meaning it does not cross the x-axis. This is a special treatment from the function itself, known as the determinant. When the determinant is negative, there are no roots. When it is positive, there are 2 roots. And when it is 0, there is 1 root. An interesting fact to hold on to. Let's get back to the problem. Because it is negative 31 and there is no square root for negative 31, we know for sure that number 2, 2x squared minus x plus 4 equals 0, has no real roots. Make note of that. So let's talk more about the number under the radical in the quadratic formula. If after you simplify and the number is positive, that means the quadratic equation has 2 roots. If the number is 0, that means the quadratic equation has only 1 root. And if the number is negative, that means the quadratic equation has no roots. This makes sense because there is no square root of a negative number. Okay, Let's look at number 3. X squared minus 5x plus 10 equals 0. First, we will simplify. You should have had 5 plus or minus the square root of 25 minus 40, all over 2. If we simplify what's under the radical, you'll get negative 15, which would give you x equals 5 plus or minus the square root of negative 15 all over 2. Again, we must stop and look. There is no square root of a negative number. And as we said, when there's a negative number under the radical sign after you've simplified, then this quadratic equation can have no real roots, which means it does not cross over the x-axis. Take a few seconds and make note of that. Finally, number 4. Negative 2x squared plus 2x plus 9 equals 0. Let's simplify. We should have set up x equals negative 2 plus or minus the square root of 4 minus negative 72 all over negative 4. As we know, minusing a negative is the same as addition, so it becomes 4 plus 72, which is 76. And we now have x equals negative 2 plus or minus the square root of 76 all over negative 4. Of course, we have to separate these problems because of the plus and minus. So now we have x equals negative 2 plus the square root of 76 over negative 4, and x equals negative 2 minus the square root of 76 all over negative 4. Remember, we do this because the quadratic formula has the plus minus. If you plug this into your calculator, you should get x equals negative 1.68. And for the other equation, you should get x equals 2.68. Check your work. Football is a globally loved and supported sport. But like all things, math can be used to describe a lot of what happens in the sport. Let's take a look at a problem. Let's say the Al Jazeera Club decided to buy a new machine to help players work on their kicking mechanics. The machine scans the players' bodies as they kick the ball and gives advice on what players are doing wrong or what they could do better. The machine also prints out quadratic equations about each player's kick. If the midfielder Omar kept getting the equation negative 2x squared plus 10x, how far was he kicking the ball? I'll give you a hint now. You have to find the difference between the roots of this equation. Go look back over your work that we've done during your assessment and see if you can put it together. Feel free to pause while you work on the problem. So your first instinct should have been to look at the equation, negative 2x squared plus 10x. You tried to plug it into the quadratic formula, hopefully. Of course, there should have been a question, or maybe there wasn't if you understood. What does C equal? Well, A should be negative 2, and B should be 10. But the equation lacks a constant, a number by itself without x. In that situation, we say C equals 0. Pause and go ahead and check your formula and make any corrections that you need to before checking with me. So you should have, for the quadratic formula, negative 10 plus or minus the square root of 10 squared minus 4 times negative 2 times 0 all over 2 times negative 2. Take a few seconds and try and simplify under the radical sign. You should have now negative 10 plus or minus the square root of 100 minus 0. We get 0 because 4 times negative 2 times 0 gives us 0. And when we simplify further, we should have 100 minus 0 equals 100, which means the number under the square root symbol in our formula is positive. This lets us automatically know that this particular function will have 2 x-intercepts, which should make sense because the ball was kicked from the ground and went up in the air and landed back on the ground, kind of like a parabola. Let's go ahead and finish the simplification. We have to split it up now. You should have negative 10 plus the square root of 100 over negative 4, as well as negative 10 minus the square root of 100 over negative 4. Since the square root of 100 is 10, you should have negative 10 plus 10 over negative 4 and negative 10 minus 10 over negative 4. This would give us 0 over 4, which means x equals 0, as well as negative 20 over negative 4, which equals positive 5. So our x-intercepts would be x equals 0 and x equals 5. If the equation's in meters, can you tell me how far Omar kicked the ball? Take a few seconds and think about it. If we think of the x-intercepts as where Omar started when he kicked the ball and where the ball landed when it hit the ground, then it went approximately 5 meters, if that's what the equation was telling us about in distance. So think about it. Using quadratic equations can be helpful and applicable to real life. It's just all in how you look at it.